Now we switch our attention a little bit. We're not talking about concentration anymore, but what is the composition of the solution and what's it look like molecularly? Okay, we're going to start talking about electrolytes. What is an electrolyte? An electrolyte is a substance that dissolves in water and it yields a solution when it dissolved that is able to conduct electricity. Obviously, a non-electrolyte is a substance that dissolves in water, but it doesn't yield a solution that is able to conduct electricity. In this picture over here, we have in the red and white colors, these are the water molecules, and this is NaCl, salt. And so when I put NaCl in water, what is going to happen is that all of the water molecules, remember that it is a polar molecule. That means that it has permanent dipoles. And it has a separation of charge. It's going to have partial positive charges by the hydrogen and a partial negative charge by the oxygen. All of the positive ends are going to align and get close to the chloride anion, and they're going to interact with it and be able to pull it off, suck it off, if you will, from the rest of those ions that are interacting with it in the crystal. The same can be said with the sodium ion. Sodium ion is going to be surrounded by the negative side, so the oxygen side of the water, and they're going to pull the sodium ion off the crystal, and that is how the dissolution process happens. Now you can see pictorially why we can only dissolve a certain amount of solute in a certain amount of water, and that is because it takes a few molecules per ion, a few molecules of water per ion to be able to surround each ion, and I will run out of I'll run out of molecules of water. And note that it isn't a 1-to-1 ratio. Actually, it's a 6-to-1 ratio or thereabouts, right? Now, once I have free ions in solution, this solution then is able to conduct electricity because it has free ions, and it is a good electrolyte. Substances that are, especially molecular compounds, those are not ionic. They have covalent bonds. So when we dissolve them in water, they can dissolve because they will be polar molecules and they will have dipoles and they will be attracted to the positive and negative ends of the water molecules. But when they dissolve, they don't have charges, full charges, so they are not free to conduct electricity. Here's how we kind of test for electrolytes. We can actually hook this up, hook a battery up in a light and see whatever lights the solution and what doesn't. Here is pure water. I have nothing dissolved in it. And as you can see, if I have pure water, there is no electricity that flows through that circuit because I don't have any ions really in solution. Well, let's take a look at this one here. This is glucose, sugar. So glucose is dissolved in water, dissolves very well, but because it is a molecular compound where it doesn't split into ions when it is dissolved, then it cannot conduct electricity. It is not a good electrolyte. Here is sodium chloride that is dissolved in water. Well, now I have all these free ions that are roaming around the solution, and when I pass a current through it, I complete basically the current, and I can light up that light bulb because there is current that runs through it. It can conduct electricity, and it's a good electrolyte. So what makes for a good electrolyte? A solution that has free ions. A solution that doesn't have ions is not a good electrolyte. Now I can have different levels of dissociation of ions, and I can also see that For example, if I take, these are all ionic compounds that dissolve in water, but they will split into several different ions for every molecule. And obviously, some of those that have higher ion dissociation will be better electrolytes. Let's take a look at barium nitrate. Okay, for every barium nitrate molecule, note that I will have one barium that splits, but I will have two nitrate ions. So I'll have a total of 3 ions in solution for every molecule of barium nitrate. What about aluminum chloride? Well, I have 1 aluminum and 3 chloride ions, so a total of 4 ions for every molecule of aluminum chloride, which means that this produces more ions in solution and therefore will be a better electrolyte. What about here? I have 3 sodiums and 1 phosphate for a total of 4 total ions in solution, so this will also be a stronger electrolyte. When we look at the formulas, the ionic formulas, you can count the ions, right? 1 barium, I have a subscript of 1, even though it's not written, plus the 2 nitrates. Don't confuse, that belongs to the oxygen, but this 2 belongs to the total ion. So I have 1 plus 2, that gives me 3. Here I have 1 plus 3, that gives me 4. And here I have 3 plus 1, even though it's not written. The 4 belongs to the oxygen, but this whole unit would be a 1, and I don't have to write it. That gives me 4 total ions. Here's a sample problem for you. So determine the concentration of chloride ions, so just the chloride ions in molarity in each of the following solutions. So here I have lithium chloride. For every 0.15 molar lithium chloride. Well, this is the molarity of the solution, but I have a 1:1 ratio between chloride and lithium chloride. So that tells me that I will also have the same molarity of chloride ions in lithium chloride. Here, however, I have twice as much chlorine as I do MgCl2. Here I have 3 times as much. So go ahead and work on these and figure out the molarity of the chloride ions in these solutions.